Ally PLM.
Hi, my name is Ben Weisenberger. I'm an application engineer with Ally PLM Solutions. I want to welcome you to the Ally PLM LunchByte series. In today's video, we'll be taking a look at adjustable and alternate position assemblies inside a solid edge. So for today's agenda, like I said, we'll be taking a look at how to create both an adjustable and an alternate position assembly. We'll take a look at how to define our member properties as well as how to use those alternate assemblies in other documents. After that, we'll take a look at animating an adjustable assembly and some enhancements that were added in ST8 to help with that. Then we'll learn how to create an alternate position assembly and display that in a draft file. And then finally, we'll also take a look at some other new adjustable subassembly enhancements that were added in ST8. So let's go ahead and get started. So real quick, just a quick review of what an adjustable part was. I'm going to show you a quick example of an adjustable part of a spring, and I'll explain why later on. But in some designs, there are going to be parts that need to react to changing conditions in the assembly. And again, just in this case, a spring. The adjustable part functionality in Solid Edge, it allows us to define different parameters in our part model that will adjust to corresponding parameters within the assembly. So after specifying a part as adjustable, the design body in the part model doesn't change when the assembly changes. It's actually an associative copy of the design body that'll change. What that does is it allows us to place several occurrences of that adjustable part into an assembly, and then each occurrence of that adjustable part will conform to whatever parameters are adjusting for that occurrence of the part. In this case, in the example below, you can see one spring is compressed while the other one is shown uncompressed. So I'm going to create a spring here in just a minute for you. Then we'll add that into an assembly and we'll adjust the assembly so you can see how those adjustable parts work. Then later on we'll take those adjustable parts and adjustable subassemblies and place them into a top level assembly and make some adjustments with them as well. So the adjustable assembly functionality will enable us to move or create movement within a subassembly while working in a higher level assembly. If a assembly is a rigid assembly, you wouldn't be able to move it. So in this case we have a hinge. We want to be able to move the hinge to move the doors of this cabinet. We need to make that an adjustable subassembly that'll allow us to move then the hinge accordingly and move the door on the cabinet. What that also does is it allows us to show that subassembly in different positions in different locations in our top level assembly. So you can see here in the picture below that the hinge is open or closed in different instances here in the top level assembly. The adjustable assembly functionality also eliminates the need to have multiple copies of identical subassemblies. That eliminates then having unique names for each one of those subassemblies. We can just have one subassembly with one name that we can use over and over again to display in different positions. That'll give us then a completely accurate bill of materials for all those identical subassemblies, again without having multiple unique names for all the separate subassemblies. So in order for us to take advantage of those adjustable assemblies, you have to leave your subassembly under constrained in the range of motion that you want to be able to adjust. So again, with this example below of a hinge, you can see we have the movable hinge part under constrained. So in our Pathfinder, you'd see that that part could still move slightly. In this case, we want it to be able to rotate about the hinge pin. So we've left that under constrained. As we bring this subassembly, the hinge subassembly, into a top level assembly, we are then able to define it as an adjustable assembly and move it accordingly. So a couple different ways that we can specify an assembly as an adjustable assembly. Upon placement of the assembly, if you are in the assemble command and you go into the options button on the command bar, there's an option to place as adjustable. Also, if you right click on a subassembly inside of a top level assembly, you have the option to come down to simplified adjustable and switch it between an adjustable assembly or a rigid assembly. Now, if you have a subassembly that is fully constrained, all of the parts inside of it are fully constrained, you won't be able to mark it as an adjustable assembly. Again, from our last slide, you have to make sure that it is not fully positioned. You have it under constrained in the directions that you want to be able to move the part. So back to our hinge example, you would need to leave that hinge part under constraint so it could still rotate. Another way you can specify this is actually back in the assembly or the subassembly. Um, if you go into the solid edge options button on the assembly tab, there is an option here to place as adjustable when this assembly is placed into another assembly. It'll remember that setting then for this specific assembly, again our hinge example here, so that anytime you bring that hinge assembly into another assembly, it'll automatically be placed as an adjustable assembly. When you specify that one of your subassemblies is adjustable, you're prevented from in-place activating into the assembly. So just for an example, if we place that hinge subassembly into a top level one, you click on it and go into the edit command, it's going to pop up a little dialog box saying, hey, you can't do the edit in place. You have to actually open up that subassembly to make any edits to it. If you already have a subassembly defined as an alternate assembly, you won't be able to then create it as an adjustable assembly. Also, as I mentioned earlier, you have the option to switch back and forth between an adjustable assembly and a rigid assembly. You can do that just by right-clicking on it, going back into that simplified or alternate assembly option, and changing it back to a rigid assembly. Now in ST8 there are some pretty cool options that were added. There was a new option called the variable table motor. We're not really going to cover that in this LunchByte, but there is a previous LunchByte about what's new in ST8 that'll cover more about the variable table motor. We can use that here though with our adjustable assemblies to animate them. Now what goes along with this are some animation options that we have. Previous to ST8, when we did an animation, there was only one option. It was a relationships option, which solved our animations. Now there are two new options in ST8 called active assembly and active level. So I'm going to go through this example in the slides, and then we'll do it in an example. I'll show it to you in just a minute. But in this example here, we have two plates with some springs between the plates. We have a linear motor that is simply pushing down the top plate towards the bottom one. In the old behaviors of ST7 and before, with that relationship behavior, all it would do was move the plate and the spring would not update until the animation or the movement was done. So it was always difficult. We couldn't animate springs. What we can do now though is use the active assembly option in ST8. What this does is it allows us to animate relationships, variables, and formulas in the active assembly, and also update any measurement variables. This includes patterns, included edges and assembly sketches will update. The things that we're covering here, assembly parts and assemblies, the things that we're covering here, such as adjustable parts or adjustable assemblies, will also update now. Frames, pipes, wires, sketches, assembly features will update. What this does is it also freezes inner part relationships during the animation. So if we use this active assembly option, we can now get those adjustable parts or adjustable subassemblies to update. Just to go a step further to show you the last option, the active level, this will allow you to update relationships and variables from the active assembly and down into the subassemblies. So it's very much like running the update active level command after each frame of animation. Adjustable parts will update, frames, sketches, assembly features will update as well, and inner part copies or inner part relationships will update. So in this example we have a hose here made in express route that has a tube and inner part relationship there that resides in the subassembly, and that'll update now with this active level option. So I'll show you all three of those settings and how they work in an example in just a minute. Now there are two main types of alternate assemblies, alternate position and family of assemblies. We're not going to cover family assemblies in this LunchByte, but it was covered in a previous LunchByte. So I will link that here so you can go back and watch that if you want to learn more about family of assemblies. We're going to be covering alternate position assemblies though. So for an alternate position assembly, all the parts must be identical for all of our members. In an alternate position assembly, the part positions can change, which is ideal for showing positional changes of things like mechanisms or linkages or switches, things that are going to be open or closed. So to create an alternate position assembly, we're going to convert the active assembly into an alternate assembly. To do that, we simply click on the alternate assembly tab over on the edge bar, click the new button, and that'll bring up the alternate assembly dialog box. On the alternate assembly dialog box, we're going to specify if we want to create a family of assemblies or an alternate position assembly. So in this case, what we want to do is an alternate position assembly. Now, just keep this in mind. You cannot come back and change this type later. So you have to make sure you pick the correct version. Otherwise, you have to recreate this again. Now, we're going to name our first two members. So in this case, we have an example of maybe type 1 open and type 1 closed. Whatever you have as the new member, when you click OK, that'll become your active member. Now, as you're going through and creating your other members, you have the option to apply edits to all members, which is a global modification, or you can simply do a local modification and affect only that one active member. So this would be, again, going back to editing the type 1 open or type 1 closed. If I have this box unchecked, it's only going to edit, in this case, type 1 closed. And if I have that box checked, then it'll edit all of the members. We can only have one member active at a time. So there's a drop-down list here. You can pick which member you want to be active, and it'll simply change the parts to match whatever you have picked from that list. Now there's a Save Member button on the Alternate Assembly tab. What this allows us to do is save out that specific member as a new assembly then. That new assembly that we save out is not an alternate assembly. It saves it out as just a regular old assembly. You could then go on and add new parts or make other changes to the assembly if you needed to. Now in ST8 they added some new enhancements to work with adjustable subassemblies. There's a new option that now supports override relationships on any relationships that is defined inside of an adjustable assembly. So this is going to give you the option to control from your active level assembly any predefined relationships within your subassembly. So a couple of the advantages to this method means that the subassembly can be fully defined within the subassembly. So that allows you to test all the subassembly mechanics, make sure all of your relationships are working correctly. Once that subassembly is placed then in the active level assembly, you can promote those relationships from the subassembly and control them from the active level. Once those relationships have been promoted, it's moved from the subassembly to the active level assembly where it can then be easily edited. You'll notice when you click on that subassembly, it shows the overridden relationship at the active level. You also notice that the adjustable assembly icon is next to that relationship. Another advantage with the overridden relationship value is that it can then be set up using the variable table, which can then be driven with our new variable table motor in ST8. An overridden relationship, it can be suppressed, fixed, floated, flipped, etc. When overridden, that relationship will appear in the variable table of the owner assembly. You'll also notice in the comment field, a variable will be added with the display name of the subassembly that relationship comes from. So in a little bit, I'll show you an example of how we can use that adjustable assembly override in the variable table motors to animate those adjustable subassemblies. So let's go ahead and get into Solid Edge and take a look at some examples. Alright, so for our first example, we want to open up just a part file here, and I want to show you real quick creating an adjustable part. So I'm going to create a spring, so I've got a couple sketches. Let's go ahead and edit into that sketch and take a look. Got a couple dimensions over here. I'm going to create one more dimension. We're going to use this dimension then to drive the model or our adjustable part. So we've got a dimension of 2000 millimeters here. So if I go into the variable table, we can see that length, and I can rename that variable. I'm going to give that a name, something like spring length. So after we've renamed that variable, we can come in here and create a parallel plane, and I'll show you why we want to do this in just a minute. So I've got another plane in there. What we're going to do then is create a helical curve, or a helix, around that axis in the middle. So I'm going to select my circle. Then I'm going to select my axis and my anchor point where I want to start from. Now I'm going to create my helix by using the axis length and turns option and do 15 turns. Now something that's really cool, we can use those planes and do a from to extent. What this does, and let me select the right surface here, what this does is it'll trim off the end of our helix so that it is flat along that plane. So that just makes it easier. You don't have to come in later on and do some sort of a cutout on the end to cut those off. So what we're going to do then is make this an adjustable part. So under the Tools tab, we can come up here and do an adjustable part. I want this to adjust like a spring, and I'm going to go in and select the variable that I want to adjust, which is that spring length variable. I've got that selected, and now you see this is listed as an adjustable part. We're going to use that adjustable part then in an assembly. So I'm going to open up an assembly that I have here. So I've got my assembly, just a couple cylinders, some shock bottom, shock top subassemblies that I have here. We're going to add that spring then into the subassembly. So I'm going to come over here and bring my spring in. Now you have the option to place this as adjustable or rigid. I want to place this as an adjustable part, so I'm going to hit OK. Now it's giving me some options how I want to place this in here, how I'm going to adjust that variable that we added to the spring length. So I'm going to take a measurement between 2 points, and I'm going to measure between these 2 key points on the 2 shock top and bottom parts. So now it has that value. When I hit OK, it'll then adjust the length of the spring so that it fits between those 2 parts. I'm going to add then some assembly relationships. I'm going to align the axis of the spring to the axis of the cylinder, and then I'll do a couple mates on the top and bottom faces of the spring to get that guy fully constrained in there. So now that I have my adjustable part, if I come in here and do a drag component and move this up and down, when it updates the length of my spring. So we're going to use this subassembly then in another top level assembly. So I'm going to come over here and open up another assembly that I have. I'm going to go into this arms assembly, and we're going to bring in that adjustable subassembly that we created with the adjustable part into this assembly here. So let me find my shock absorber. I'm going to bring that into this assembly. We're going to add some constraints here. So I'm going to grab the cylinder at the bottom to this, same thing at the top. Let me make sure I get the cylinder. And then I want to center this up. So I'm just going to use some reference planes to center this guy up in the middle of that part. So now that we've got it in there, I want to make this adjustable. Now, when I was placing that assembly, and when you're in the assemble command, you can come into the options button. This allows you to place it as adjustable. Now I already have it fully constrained, so I can't do this, but I could have done it upon placement of that subassembly. The other way I can do it is I can right click on that, go into simplified adjustable, and turn this into an adjustable assembly, which I'm going to do. So it's going to give me a warning here. It'll promote it to an adjustable part definition. Do you want to continue? Okay. Now it's listed over here in my Pathfinder as adjustable. What I can do now is drag that component and make a change to it. So I can come in, grab this part, and start to drag it. When I let go, the spring will update. Same thing if I make it smaller. Again, my spring updates. So now I am able to adjust that subassembly as an adjustable assembly with my adjustable part, which is the spring. If that were a rigid assembly, I wouldn't be able to drag that component. So just to show you that real quick, I can right click on the adjustable assembly, come back in and make it rigid. I'll hit OK and make it a rigid assembly. Now if you try to come in with drag component, I can't move any of these components because it is rigid. So by making that an adjustable assembly, I'm able to move it as the way it was constrained in the subassembly, which would be to expand or contract and change the length of that spring. Now, we talked about in the PowerPoint some new options with animating those adjustable assemblies. So I'm going to open up an example here that I showed you in the PowerPoint. So this is the same assembly. I've got two plates here with some springs in between them. Now I've got a motor applied to this already. It's just a linear motor that's going to push the top plate down. I have then my adjustable part, which is my spring here. So it's not in a subassembly, it's just placed right here in the top level assembly. I'm going to go in and simulate that motor. So I've got my motor added here. The default behavior, which is what would happen in ST7 and before, is to use relationships down here. So if I hit play on that, you see the plate just moves down and my springs don't compress. So it's not updating my adjustable part as it animates that. What we have now are some new options underneath here. So what I want to start with is the active assembly level. So we're going to update all of the adjustable parts that are in my assembly. So if I play now, you'll notice the springs compress, which is awesome. You'll notice though the hose didn't quite adjust. That flexible hose is in a subassembly, and it is an inner part copy or inner part relationship that would update for the length of that hose. So with the other option we have, active level, it'll go down into that subassembly and update it. So this does sort of an update all links after each frame of the animation. So it will animate a little slower because it's doing some more calculations. But once you save this out into an animation, to a WMV file, something like that, it'll play smoothly as just a regular video. So some pretty cool options that we have now with creating animations of adjustable parts and assemblies. Next thing I want to take a look at is an alternate position assembly. So I'm going to open up a robot arm here that we have created. We're going to go in and create some different positions of our assembly. So over on the left here, we're going to go into the alternate assemblies tab. We're going to define a new member. Now I want to create alternate positions, so I'm going to select that option here. I'm going to give the current member a name. This is going to be considered my home position. My new member I'm going to create is called Elevate, and we're going to lift that arm up. So I'm going to create both of those and hit OK. And now we see over here I'm on the Elevate option. Now I'm going to add some variables in here, and we're going to drive those variables to make a change in the position of our assembly. So I'm going to go into my variable table, and I want to grab the Elevate variable, and I also want to do the wrist position, or excuse me, the arm extension. So I'm going to grab arm extension and add in that variable as well. So now that I've got them both added, I'm going to drive those and make changes to it. So I only want to make a change to this member, so I'm going to leave this option unchecked. If I were to have this option checked, it would do this change to all my members. So it would also do this to my home member, which I don't want to do. I just want to edit Elevate. So I'm going to select that. I'm going to come down here and change my Elevate setting to 3 inches, and you can see how it lifts the assembly up. So basically that's all we're going to do, is we're going to go in and define different positions and change these variables in each one of our positions. So I'm going to create a new member here, and this one I'm going to create extend 25%, and I'm going to move that arm out 25% of the way now. So I'm going to create my new member, and this one I'm going to edit the arm extension. Now this remembers the value from the last member, so it's going to keep my Elevate dimension or value to 3 inches, which is what I want in this case. If I didn't want that, I could always change it now. So I'm going to go in and create a new member here, which was my extend 25, and I'm going to type in an arm extension value of 1.75 inches, and there we go. Now you see as the arm extends out, it also rotates the wrist down here. You'll notice that gets more pronounced as we add more length onto that arm extension. Alright, so that's our extend 25% member. Let's create another new one. This one we're going to extend 50%. I'm going to change my arm extension value here to 3.5, and we get a little bit longer, and I'll just keep going on creating new members. This one's going to be my extend 75% with an arm extension value of 5.25, and then I need a full extend value, so I'm going to do one more member. I'm going to do full extend, and I'm going to change the arm extension value to 7 inches. So now we're fully extended. Now I can go through and change and go to any of my existing members. So maybe I want to go back to my home position. I can toggle through and take a look at each one of my members here and see what happens to my assembly. So now that I have my assembly done, I can go in and create a drawing of it and display each one of those members on that drawing. So I'm going to open up a draft file I have created here, which just has an isometric view of the assembly on it. I'm going to go into the view wizard and I'm going to select my assembly here that we just created, and I can pick what view I want to be displayed on here. So I'm going to start with the home view as my primary view. Now I could turn the other views on. I'm just going to start with that one for right now and create this view. I'm going to go in and create this as a front view and place that somewhere here onto my drawing. Now I could go back in, I can right click on that view and say set primary and alternate positions and turn my other positions on. So maybe I want to turn on my full extend as an alternate position. So after I turn that on and update my views, I see that other position shown here on that view, which is pretty cool. Now I can go in and I could turn on other ones. Maybe I want to turn on elevate, and let's go 50% and full extend, something like that. So now I've got multiple views. Now they all look like they're on top of each other, which they are. A little difficult to see because they're all black. But what you can do is set up view styles to make that easier to visualize. So I can go into my properties, and up here at the top left I see all of those different views that I've created. So my home view, I want to be the home style that I've created. My full extend, I'm going to change that edge style to my full extend style. My full extend edge style. I've created one for elevate and one for 50% as well. So you can go in and adjust the settings for each one of these alternate positions. I can show and hide subassemblies from each one of those. I could turn on hidden edges for each one of those. So a lot of options that you can do with all of those alternate positions. So I'm going to hit OK, and when we come back now we can see that they're all displayed in different colors. Makes it a little easier to visualize which view is what. I can come in then, maybe I want to add some dimensions in here. So how far is that difference in the full extend, which is that 7 inches. So you can then fully dimension all of those alternate position views if you want to as well. So some really cool options you have here in the draft environment with alternate position assemblies. The next example I'm going to show you is another alternate position assembly. So let me get my assembly open here. This is a ball valve. What we're going to do is adjust the valve to make sure it's open or closed. And in this case, if we look through it, we can see all the way through. Our handle is in the open position. So I want to create this as an alternate position assembly. So I'm going to go and do a new member. I want to create an alternate position assembly. My member 1, that's fine. I'm going to keep the names as they are. Or actually, let's do open and closed. So I'm going to type in open, closed, and create my 2 members. So now in my closed position here, what we need to do is go into our variables, and I want to adjust my valve angle. So the valve angle was used as an assembly relationship to create the angle of this handle and how it should be located. So I can come in and drive that, and I want to add that as one of my variables over here to drive my members. So for my closed member, I want to make this value 90 degrees. I want to turn it 90 degrees and close the valve. And as I do that, you see it closes our ball valve down there in the bottom. What you could do then, if you wanted to save this out as a separate assembly, I could go in and do save member as, and then save this out as a closed assembly. And then I could open it up and do whatever I wanted to my closed assembly there. So you can see we have open or close, which opens and closes that handle. So just another quick example of the alternate position. Now, to go one step further with this, maybe I don't want to create this as an alternate position assembly, but I wanted an adjustable assembly, and I want to animate that handle opening and closing. So they've created some enhancements in ST8 to allow us to do that. So I'm going to open up a larger assembly here that has a bunch of these valves that I just showed you in it. Now you'll notice on this assembly, most of the valves are already adjustable assemblies. So you see valve 1 to 5 are all adjustable. What I'm going to do is show you how I made those adjustable and why we did that. So if I click on my last valve down here, what we want to do is be able to drive the angle of the handle. Now right now I can't do that. It is a rigid assembly. and I can't drive that. It's being driven down in that subassembly by an angle relationship from the angle of this handle to one of the faces on the other component. Now I want to be able to drive that from up here in my top level assembly and change the angle of that using our new variable table motors. So I need to make this an adjustable assembly. So what I'm going to do is just right click on that valve, change it into an adjustable assembly. What I can do then is go inside of it, find that part file, my handle, and here is that angle measurement that is driving the angle of my valve, which is going to make it either open or closed. So our new option we have here is under the right click menu, I can do an override relationship. So by overriding that, it adds it to the adjustable icon here. That brings it up into my top level assembly. So if I simply just select on that subassembly here, it now becomes one of the assemblies that I can edit in my top level assembly. So now this got created as variable 2906. So let's go into the variable table, take a look at that one. So down at the bottom, here are all the angles for the other 5 valves, and here is that last one that we just created. So what I can do is adjust the angle of this. So let me zoom in some so you can see this better. If I change that from 0 degrees to 90, you see it rotates my handle. So that's the benefit of this override relationship option. Now I can drive that from here in the top level assembly. Now I have that driven off of a formula for all of the other values. So I'm going to go in here and make this one equal to that. I want to do it equal to open close. And now it's driven by that formula. This value here now, if I change that, and maybe I change it to 90, they all switch positions. So I can now drive all of them through one variable. What we can do then in ST8 is drive that variable with a variable table motor. So I have a motor created here that is driving that value. It's increasing it a certain value up to that 90 millimeters. So if we drive that variable, we simulate this, simulate that motor, we can see all of the handles rotating slowly. Now I have this saved out to a video, so let me play that video for you real quick. And you can see all of the handles rotating together just by moving that one variable table motor. So some really cool options that we have now with adjustable assemblies and the variable table motor. So that's all I had for you guys today. If you have any questions for me or any topics for future LunchByte sessions, please email them to me. Once again, I appreciate your time. Thanks and have a great day.
LIPLM